Okay, so we're back with a small aside on how to add and make sure that all these files that you are writing and uh, compiling, how to make sure that they're all making it correctly into the repository and they're correctly in version control. So I'm going to begin with the assumption that you have Git installed, which means in a terminal you should be able to do, Git version, and whether it's on Linux, which means you have a bash terminal, or you're in Windows, which means you have git bash installed or something like that, where at least at a minimal level you have a terminal where you can do git commands. So that's the assumption, and we'll take it from there. So the first thing that you want to do is whenever you are in a repository like this, you go here. First we'll cd and change directory into the correct repository. So this is the workspace directory. Okay, so the first thing that you want to do is to run a command that basically is git init. Okay, so what this is going to do is it will initialize git and tell git that okay, this is the folder that we need to start watching and we need to start looking at. The benefit of doing git init within this workspace folder, which means in this top level workspace folder. Okay, so let's be careful here. This is the folder that contains all our projects as individual directories, and it contains this folder called dvt and whatnot. Okay, so we are initializing git in this top level folder, which is the workspace. And the advantage of doing this is that a single git repository is now going to contain all our projects, which means by the end of the semester, let's say you worked on 10 different things, which is one is going to be a blink, one is going to be uart, whatever else you are doing, all of those basically will end up in one repository, which means that is the combined repository that you can keep for future reference and whatnot. The downside is, of course, you may not want to keep all of these different pieces of code in the same repository. You want to have one repository per per project or per let's say per assignment or something like that. Then you shouldn't do git init here. You should go into the folder. For example, this is the folder that contains our blink project. You should do git init here. That is the only main difference in approach based on what you want. So you should decide what you need to do. For this case, because I'm going to be creating a repository that I intend to share with all students, and I want it to grow year over year. So of course I'm going to do git init in this repository over here. So I ran git init, and it said because I had already done this, I had already done git init earlier, so it just gave me this message saying that it's reinitialized existing git repository. So it recognizes the fact that there's already a git repository here, and therefore basically we don't need to do anything more, but there's already an existing git repository and we are all good. The next thing is, of course, to add things into the repository. So let's cd into our blink directory, and we have so many of these folders. Okay, so we have quite a few of these folders out here. Now the problem with this is, now of course there are some files that we need to add into our git repository, and what are those files? Those files are main.c, the cmd file, which is our linker command file, this file here, which is a header file, the startup code, which is a C file. All of these things definitely we need to add into our project. We need to keep track of them and we need to put them into Git. The second thing is there are some hidden files which are not being shown right now. So for that, we are going to do ls minus LA. Minus L is for long form. A for show all files, it means show hidden files also. And H stands for human readable. So it will show the file size and bits and bytes instead of, the, kilobytes, megabytes, and so on, instead of just the raw byte number. So these are all the files that are present. So now we need to add 1, 2, 3, 4, 5, 6, 7. All of these files need to be added. Okay. The downside is there are a lot of files that don't need to be added. So all of those files are inside this debug directory. So what are these files? They are basically your map file, which is the result of your linker output. They are the out files, which are they are the object files .obj, which are the result of compilation of each of the uh, C files. So for example, main.c gave us main.obj. Then we had a startup.ccs file that gave us our startup ccs.obj and so on and so forth. Those got linked and finally gave us our out file and our map file. None of these we need to keep track of in our Git repository for two reasons. One is they're binary files, and the other thing is that because they are built from source, every time you download the source, you're supposed to build them yourself rather than keeping track of executables in the Git repository. So that's general convention. So we are going to stick with that. Now I need to tell Git not to track all of these files. Now, of course, one way is, I just ignore them and I don't do anything more. But I can actively tell Git not to look at these files ever. And the way to do that is to go into the top level directory, which is this one here. And I'm going to create a file called git ignore. Okay, so to do that, either you go into a text editor and create a file called git ignore, or I can go into my Vim, which is a text editor, and I can go and create this file. And what I'm going to add inside this file is basically a list of all the files and directories which I want Git to not look at. So let's see what we are going to put in this. So this is the git ignore file, and what we need to add into this is basically this debug folder. What this means is no matter where it appears, debug folder should be ignored. What this says is no matter where they appear, the contents of the debug folder should be ignored. Similarly, if there is a release folder, again they should be ignored. Similarly here, contents of the release folder should be ignored. If there is an XDC help file, that should be ignored. .config file should be ignored. .launches file should be ignored, and so on and so forth. Okay. Then a few project specific things, the DVT and all should be ignored. So let's take a look at our let's take a look at the project structure and what it looks like. So this is the top level folder. Okay, this is the workspace, and our workspace folder is this ESLab 2023. So what are the things that I want Git to ignore? I want it to ignore this DVT folder. Okay, I want it to ignore the contents of the DVT folder. So hence these two lines. I want it to ignore this .jx browser .user data folder and its contents, .metadata and its contents, and remote system temp files. I wanted to ignore all of this. Git, of course, owns these Git files, so we don't have to tell it to ignore this. It will take care of this on its own. And within each folder, for example, this is Blink. So I wanted to ignore this debug and release. I wanted to ignore this .launches, and I wanted to ignore what else? Yeah, that's pretty much it. So that's all I wanted to ignore at this point. The remaining things I wanted to keep track of. I want definitely for it to keep track of the remaining things. So what are those remaining things? So let's take a look at that. So this is what I just committed last. So these are all the ancillary files. Of course, let me pull this up in a okay, so it may be easier for me to open this tool called gitg. Okay, so this is gitg, and I'm going to ask it to explore a folder called ESLab. Okay, so this is what we see in ESLab. So now in ESLab, what I see is all these files have been added: CCS project, C project, dot project, and then all these things are the dot settings, target configs, and so on and so forth. So what are these files? These are files basically that say, what board is being used, what device is being used, how is it connected, what connection, whether it's JTAG, whether it's the Stellaris ICDI, stuff like that. So of course we are going to keep using the same board or similar board on different machines. So we want this all to be carried across projects. So the idea is you keep all of these files in Git all the time. So let's get rid of this. So all of these files are there, and the remaining files you have to add all your files using, let's say, git add main.c. Then, oh sorry, we are not in the right correct directory. So git add main.c, we would add tm4c.cmd, we would add the h file, okay, we would add the startup file, and so on and so forth. So we go on adding all these files, and then when we are done, all we have to do is, once everything is added, we do a git commit, and then we are done. And then finally we have to do a git push. Of course we didn't specify the name, so I need to specify git push to where. So of course this is, again, I'm hoping that you have configured your remotes correctly, and if you have, then everything looks up to date. So now I can do a git fetch and make sure that, so there we are. So everything is clean. So the only thing that is remaining now to do is go back to our master branch and merge this branch in. So there we are. So that's pretty much how you make sure that you are tracking all the correct files in Git in with CCS. Okay, and in the next module, what I'll do is I'll go to Windows machine, I'll install Git on Windows there, and then I'll try to clone this repository, whatever I've done here. I'll clone this and see that I'm able to execute whatever code is here using the other machine.